Okay, this video is covering section number 1 of your Unit 8 Trigonometry flipbook. This is the Introduction to Trigonometry. Take a look at the top flat there. Here is your essential question. What are trigonometry ratios? What are trigonometry ratios? And I've written a basic definition for you. Trigonometry, and you can abbreviate that as trig. Trig ratios come from the AA similarity theorem. We know from that theorem class that if two right triangles have the same angle measures, then the corresponding sides are proportional. Well, we know that if any two triangles have two angles that are the same, then the two triangles are similar, and so the corresponding sides are proportional. But trigonometry deals strictly with right triangles, and that's why I said if two right triangles have the same angle measures. Now this means that the ratios of corresponding sides are equal, and we've discovered this, or we've found this out in class already. So let's kind of write that as a math statement. If triangle ABC is similar to triangle DEF, then we know the proportionality holds true, and we know that we can write our proportionality statement. Then AB over DE is equal to BC over EF, and that is equal to CA over FD. So we know that if those two triangles are similar, we can show that corresponding sides are proportional. Let's go ahead and label these triangles right now to match up with our statements. Let's say this is triangle ABC. Actually, let's write that opposite. Sorry about that. Let's change that to be ABC, and let's make this one our similar triangle, DEF. Now here's what trigonometry recognizes, that not only are corresponding sides proportional, but also the same two sides of one of the triangles is proportional to the corresponding two sides of the other one. So we can actually also write more proportionality. Okay, so here's what I'm going to write. If triangle ABC is similar to DEF, then this, and also we can write these proportions. Let's take the long leg of this triangle, or the vertical leg, AB over BC is also proportional to the corresponding sides of the second triangle, DE over EF. See how I've matched up the vertical and the horizontal, vertical and horizontal. We also can say that BC over CA is proportional to EF over FD. That's the horizontal and the hypotenuse. Those are proportional. Also, we can say another one. We can go, and let's start with CA. CA over AB, so we took the hypotenuse and then the vertical leg, and that's equal to the hypotenuse of the other similar triangle, FD over DE. Now we've just recognized here's a whole bunch more proportions that we never have written before. And by the way, that's not all there is. I can put on here and more. There are other ways to match up two sides of each of these triangles by flipping them over. There's lots of ways to write this. So if you want to put a little note down here in the margin, what does trig recognize? It recognizes that the same two sides of each triangle have the same ratios? Have the same ratios. So this is what trig is built on. By knowing this class, here's what we find out is I could pick any two similar triangles and I can set up these ratios, and by the way, the ratio of AB to BC will always be the same number. If this is a similar triangle and we know these angles are, let's say, 40 and this angle's 50 and this angle's 90 and this is 40, 50, 90, then if I write the ratio AB over BC, it's going to be the exact same number no matter how big my triangle or how small my triangle is. As long as the angles inside are 40, 50, and 90, that ratio will always be the same. And that's actually what a trig ratio is. All right, let's finish up on the other side of this page and then we'll move on. There's something very important that you need to know. And if you do not understand this idea, you will not be able to deal with trig ratios. And that is these words opposite, adjacent, and one that's familiar to you, hypotenuse. You have to know what opposite means and what adjacent means and what hypotenuse means in order to deal with trig ratios. And here's what it means. Write these definitions down as I talk through these. The leg opposite means the leg that is across from the angle you are working with. And think about it. Opposite means across from. Adjacent means the leg that is next to the angle you are working with. Adjacent means next to. If you're standing next to somebody, you are adjacent to them. If you're in one corner of the room and the other person's the other corner of the room, you're opposite of them. You're across from them. And the hypotenuse is always the longest side, and it never touches the right angle. All right, so let's label this triangle and take a look at this. So I'm going to label this as A. Let's label this as vertex B, and this as vertex C. Okay, let's presume that the angle that we want to look at is angle A. So I'm going to circle this to tell you we are looking at angle A. That's the angle we are working with, and most of the time in my videos I will be calling this the reference angle. The reference angle. It's the angle that we're working with. It's typically the angle that we know the measure of, the angle measure of. All right, if A is the reference angle, well, I can tell you right now, the hypotenuse never changes. It doesn't matter what the reference angle is. This side right here is always the hypotenuse because that is the longest side and it's the only side that doesn't touch the right angle. But the side BC and side AC, those depend on the reference angle. Take a look at side BC. It is the side that is across from angle A. And because it's across from it, this is called the opposite. I'm going to abbreviate this. This is the opposite leg of angle A. And now take a look at AC. AC is next to angle A. In fact, it touches angle A. It is next to it. That means this side, AC, is adjacent. It's the adjacent leg to reference angle A. So here's how we name. We have to know these names. What does hypotenuse mean on a right triangle? What is the opposite leg of our reference angle? And what is our adjacent leg of our reference angle? Now, one quick thing, and I'm not going to label this, but take a look. If angle B was your reference angle, the hypotenuse is still AB. That doesn't change. But now, if you look at reference angle B, AC is now the opposite leg to angle B, and BC is the adjacent leg to angle B. So, based on your reference angle, These two names, opposite and adjacent, they will flip positions. For angle A, BC is opposite and AC is adjacent. For angle B, AC is opposite and BC is adjacent. Make sure you understand this. Let's write down what we see from our triangle. In this case, we're going to write BC is opposite, and I'll abbreviate it, opposite of angle A. And in this case, we've got AC is adjacent to angle A, and the hypotenuse is just going to be AB, and that doesn't change. Our reference angle does not change the hypotenuse. Alright, because I'm coming down to the end of the video time, I'm going to stop this video and start it up on video B. It'll be the bottom flap of section number 1.